Hey guys, what's up? Welcome back to another video today. Today I want to talk about one component of your scooter which you probably used n number of times, but you never really thought, what does it actually do? I know you guys are thinking, we are in an economy, we are moving towards EVs. Or here you're talking about an engine part which is almost non-existent at this point of time. I get your emotions, but I myself have a scooter, a non-EV one. Every time the engine doesn't start, I use this component, and miraculously the engine starts running. I know many of you guys use this as well, but how many of you actually took a second to think, what does the symbol actually mean? What does it actually do when I pull on this component? If you have not guessed it yet, yes, I'm talking about the choke valve, this part. So if you have the same questions as me as to what this part is, why do we pull it, what does it do to the engine to get it started, you are on the right side of YouTube today. And without further ado, let's get started. Let's begin with one of the most important component in any two-wheeler, that is the engine, right? So for a two-wheeler, you typically use a two-stroke engine. It has two strokes, one is the upstroke and a downstroke. Now for this process to run cyclically, it is very important that the air fuel mixture which is being introduced into the combustion chamber is able to produce enough energy such that your crankshaft is able to complete one half rotation. Once it completes one half rotation, then the counterweights will start acting and it will put back the piston in the normal upright position. And once again, the compression cycle, the compression will happen, the ignition of the gases will happen. Once again, the piston is pushed down. Once again, the counterweight starts acting, and it's an ongoing process. You know what's the problem over here? The problem is, let's say the fuel does not vaporize for some reasons. Okay, if it's not able to vaporize properly, then the air fuel mixture formed is not homogeneous, or let's say it is of a slightly lower concentration. When you have such a concentration being ignited, obviously the energy released is less, right? And when the energy released is less, you are not able to rotate your crankshaft properly. The piston is not able to impart enough work onto the crankshaft so that it's able to complete half a rotation, and thereby your engine will not start running because you're not able to finish that one half cycle. And this is the kind of situation which you will find yourself in on a cold winter morning, because lower temperatures your fuel is not able to vaporize well, and it leads to a lower concentration of the air fuel mixture. Thus your engine won't start because it's not getting enough energy to rotate the crankshaft, and your vehicle does not move. To understand how to fix this problem, let's look at the place where this air fuel mixture is being formed. That is the carburetor. This is a simple view of how your carburetor is supposed to work. Okay, so in simple terms, you have a intake pipe. It has a constriction. It takes air from one end, and at the constriction you have a venturi through which your fuel is let in. The air and the fuel will combine together in this pipe, and they're let down into the engine part. And this is where you get to see two of the most important components which are directly interacted by the user. One is the throttle valve, and one more is the choke valve. Remember, choke valve. So throttle valve obviously is, yes, this throttle. So when you move your throttle, it opens or closes the throttle valve. The degree to which your throttle valve is open determines the amount of air fuel mixture which is being let into the engine, and which determines the output power of your engine as well. Now, throughout your normal operations, your choke valve is always in its normally open position. It is not constricting, it is not doing anything. It is always open. But let's say it is winter time, you're trying to start an engine, but it's not starting. So you pull on the choke valve. So when the air fuel mixture is being sucked into the engine, area of low pressure is created inside the intake pipe. And this is lower than the normal operating pressures. Usually what happens is that at that constriction, lower pressure is there. Okay, because of that low pressure, the fuel is being sucked into the intake pipe, and that air fuel mixture is being created. But when you pull the choke, the low pressure created is even lesser in magnitude, because that more fuel is being let into the intake pipe. This creates a more richer air fuel mixture. Now, when you have a richer air fuel mixture, then obviously there will be more energy coming. Because of more energy coming in, the piston is now able to successfully push the crankshaft down during the combustion stroke and give one complete rotation to your crankshaft. The cycle can be completed now. So keep your choke pulled for a little time. At the expense of little more fuel, you will get your engine running. And once the temperature of your engine increases, then the dispersing capability of your fuel will also increase because of the increasing temperature. And thereby a better air fuel mixture can be created. This can be sustained as long as the engine starts running and as long as the temperature is maintained at optimum values. And once your engine starts running, just release the choke valve. It will go back to its normal open position and normal functioning of your engine will continue on. That, guys, is why you need a choke valve. Now you understand why you have that symbol, with the two bars and one kind of a slanted line placed, right? That slanted line indicates that your intake pipe is being constricted, and when the constriction happens, a richer air fuel mixture is being introduced into the engine, which leads to more energy being released, and your engine will automatically start running, thereby starting the cycle. I hope now you guys are able to understand why you use the choke valve, what is the symbol on that choke, what does it mean, and how using the choke valve gets your engine started running even though normally you could not. What do you think about the explanation? Just let me know down in the comments. And with that said, I'll see you guys in the next video. Bye.